In this question, you are asked to apply the method of cylindrical shell to find the volume by rotating the region about x-axis now. Okay, remember that for x-axis, we have to write everything in terms of y. Very good. So let us begin. How do you visualize this object? Here you have x equals to the fourth root of y, x is equal to 0, and y is equal to 16. You could rewrite this guy as x to the fourth equals to y to be able to visualize this a little bit easier if you don't remember how to graph x equals to the fourth root of y. And then if you plug in 16 here, your x is the fourth root of 16, which is equal to the fourth root of 2 to power 4, 4 and 4, they get canceled out, so your x is equal to 2. Okay, perfect. So let us take a look at our 2D visualization for now, then we rotate it about y-axis. I'm sorry, with respect to x-axis. So here we go. The object y is equal to x to the fourth. The behavior is very similar to a quadratic equation. So this guy is very sharper than the quadratic equation. X equals to 0. This is just your y-axis. And then you have y equals to 16, which is parallel to x-axis. And this guy is y equals to x to power 4. So this is the object that you try to rotate about x-axis. Okay. When you rotate this about x-axis, you're taking the same object because of the symmetry that you have. And down here, you have this guy, right? And to give it a little bit of volume, we use these dotted lines. This is the rotation with respect to x-axis, and we want to apply the method of shell, cylindrical shell. So as usual, we need to find the circumference of the base and find the height, and then we're done. So a typical cylindrical shell is like this, right? You have a base now, you have a height now, and you need to deal with those. The height is not that difficult to see. This is your height, right? On top, it is located on this blue curve, and down here, it's located on the green line. So to find the height, you basically do the subtraction between the larger x value, x is equal to the fourth root of y, and the smaller x value, which is located just right here. So the height is the fourth root of y minus 0. So that's how you calculate your height. Then you can move on to your base as well. The fourth root of y minus 0. The larger x value minus the smaller x value. But what is the base? When you look at the base is located on y-axis, right? This is a vertical object. Depends on y. So the radius of the base is y. So the volume can be calculated using the definite integral of 2 pi times y. The radius is y. This is the circumference of your cylinder times the height, Well, the height is obvious. We did the calculation, the fourth root of y minus 0, and this is your height. Then you take the integral with respect to y. But what is the minimum y value? What is the maximum y value? Y value starts from 0 and goes to 16. This is the maximum y value you see. 0 to 16. So the volume is equal to, let us do the calculation. You have 0 to 16 of 2 pi y times y to power a fourth. Let us combine these exponents. You get 2 pi, definite integral, 0 to 16, y to power 5 over 4 dy, which is equal to 2 pi times, so you have y to power 5 over 4 plus 1 divided by 5 over 4 plus 1, and y ranges between 0 to 16, which in turns can be written as 2 pi. Here on the denominator, if you take common denominator, you get 9 over 4, so 4 over 9, y to power 9 over 4, 0 to 16. But remember that 16 is 2 to power 4. So let me move this up a little bit. The volume is 2 pi 4 over 9. And here you have 2 to power 4, 9 fourth. You can cancel out 4 and 4. And you get 2 to power 9. It's a large number. Maybe one of you can do the calculation. 8 pi divided by 9. 2 to power 9 can be written as 8 pi over 9. 2 to power 9 is 2 to power 4 times 2 to power 4 times 2. Okay, can someone use a calculator and compute this for me? 8 pi over 9 times 16 times 16 times 2, or 16 times 16 times 16 times pi over 9. If we use a calculator, what do we get? Let me check my calculator. Yes, that's correct. 4096. Thank you very much. Pi over 9. This is the volume of this object rotating about x-axis using the cylindrical shell method.